Hello all, we are going to be doing a lesson in geometry using Screencast today. We're going to start this lesson by choosing option 2, which I will show you right as we share my desktop here. So, option 2, we're going to construct an irregular polygon and label its vertices. That polygon under a 180-degree rotation. Then we're going to mirror a line and apply a reflection to that same original polygon. We're going to see, is it possible for the image of the polygon after rotation to correspond to the image of that same polygon under a reflection? So we are going to go and we are going to launch GeoGebra now, and I'm going to show you how we can solve this problem. So we're going to start by creating points at these points here. 0, 0, 0, 2, 2, 0, and then this one's got to be a little precise. So I'm going to put it in here as 0, 5, and 0.5. Now, these points are arbitrary just to give us an example of how we're going to construct an irregular polygon. This one's convex, which is very irregular and and we are now going to rotate it 180 degrees, just as requested. So we are going to start here. We're going to rotate around a point, and we're going to be rotating around point A here. So B around A, and we're going to choose a 180-degree angle, counterclockwise or clockwise. Either way, it doesn't matter based on the fact that 180 degrees is 180 degrees either way. So there's the first one, and now we're going to do this for the remaining points here. So for point B, around A, same thing. Select around a point, point C, around A. And if you want to, you can also do A with A, but it's not actually going to do anything because a rotation of one point around itself is just itself. So once we take we will connect the line segments here. C to A to B, B to and to C. So the way that we can tell that this is a pure rotation is that the lengths of these sides are now the same. I kept these relatively simple, so segment J and section K or segment K are both 2, which is what they are for G and H. For F. And then we have G, which is 1.58. And that is equivalent to L and M over here. So these are now equivalent figures. So we have this, and the coordinates now are, and this is important to remember, 0, 0, 0, -2, -0.5, -0.5, and -2, 0. So I'm going to undo the new points. I'm going to undo the rotations, and I'm going to create a line here. Now, the line I'm going to create is important that I do it this way. I put one here, and I make it so they're the right triangle after it creates an intersection on both sides here with point A. All right. Now that we've done that, we can go into this menu here, and we can reflect about a line. So we're going to reflect D around this line here, B around this line here, C around this line here, and as we'll see, the coordinates are the same as before, and let's just verify with the segments here. B to A, still 2, B to D, 1.58, D to C, 1.58, and C to A, 2. So those two translations were proven to be equivalent. I'll go over the which is good to know considering the translations that we are going. So what we are learning here is between different types of translations. Now, it's not going to be that way for every case where a rotation will always have a reflection that we're the same. It just so happens to be in this case that 180-degree rotations are all two reflections around a line of this nature. The line should be one where on a coordinate plane that I could join. Let me show you this. If I were to create a midpoint here between B and A and attach a segment to E and G, this right here should be able to make a right triangle using the line that we'll be reflecting around. If it can do that, it will be an equivalent reflection to a 180-degree rotation, which that's very important to know because when we go back to our standard, we are trying to see these different relationships between different translations. And now we know that a rotation of 90 degrees, or sorry, of 180 degrees about the origin and reflection across an axis of this nature is the same thing. It can be good for students to use because now they will know that these two things are equivalent, and they will also understand that they can use the same thing, like they can use these two different methods to solve problems of similar nature. This is very important because and two can work the same way, be a huge leg up for them. So that right there was my lesson. Thank you for tuning in, and I will see y'all in class.